Well, ladies and gentlemen of YouTube, here's a hat I didn't think I'd wear for a long, long time. Yeah, after being a tech for almost 30 years. 1 week ago today, on Monday, April the 11th, 2011, Ten Loop Ranch suffered minor lightning damage. The house didn't get hit, but something outside got hit, and it was near enough to where the lightning current, as it traveled through the ground, it came up through the ground connections. Apparently the one on the west side of the house for the direct TV and the incoming power, and then on the east side of the house through the phone system ground, and somehow they connected in the computer or in the video equipment or somewhere, I think in this room, and we did sustain some light damage. We didn't have any sparks jumping in the house. None of us were in danger, thankfully, by the grace of the Lord above, and damage was minor. Not very much current got into the house, and like I was joking with the hat, I was an electronic tech for almost for about 27 years. So I went ahead and repaired the damage myself. Didn't have any blown circuit boards, didn't have any burnt spots, didn't have any melted wires. Just a little bitty bit of energy got into the house and damaged a few things. So what I'm going to do is I'm going to do kind of a little slideshow of stills and then narrate those. Well, before I do the stills though, the ThunderMike was operating at the time, since I record VLF and also outdoor weather sounds along with the Weather Channel's video and Weather Channel audio at real low level in the right channel. I managed to catch the lightning strike that actually caused the damage. So before we do the still picture slideshow, I'll go ahead and show you the ThunderMike video with the Weather Channel in it, and at 4 minutes and 4 minutes and 7 seconds and 4 minutes and 8 seconds the lightning hit. If you watch real close while the video is running, you'll see that the DirecTV's screen, the screen that announces that there's no signal available or searching for a signal or whatever the thing is, you see it go dark in a couple flashes right in the middle of a huge loud blast of thunder, and that's the one that took it out. First thing I noticed is it took the video input of the DVD recorder out, and it only took the front panel input, so the rear channel input still works, and it didn't do any other damage, so the recorder managed to catch the strike that got it. And I just rerouted all the audio and video into the rear panel, and also added grounds and static discharge to the video switcher in the ThunderMike system. So hopefully, unless we get hit worse next time, we should be able to continue to use the equipment. So without any further ado, I'll go ahead and I'll hook it up, and we'll cue up the video and let you hear it. Around 4:07, 4:08, somewhere like that on that video. Be a huge blast of thunder, and it'll kill the video. Still shot number 1. Up in the upper left you see the right hand side of the DVD recorder. Video input, the lightning blue, left audio, right audio in. Underneath is the VCR. As far as I know, it was unaffected. To the right is the ThunderMike system. The bottom unit is the audio mixer. It's in the ThunderMike mode, and that mixes both audio channels from the direct TV box and feeds the mono mix to the right channel of audio. Also, the adjustable gain preamp with the outdoor microphone, and I'm using a Panasonic WM61A alpha mic element, full range mic element. Have a high pass filter at 50 Hz so the car stereos and the subwoofers don't bother it too much, and does a magnificent job of recording full range thunder, wind, and rain and other weather sounds, so it's kind of handy. You can turn that thing on and give it a listen and kind of hear what the weather's doing, tell how much wind there is out there and the rain and all that. At one time I had the video switch box on top attached with cable ties. Since I had to go in there and modify the ThunderMike system, I went ahead and used regular screws and nuts to bolt it all together. Also, instead of running an audio jumper from front to back, I went into the switcher and cut into it, and now the ThunderMike audio is routed through some cables coming out of the back of the switcher, so it's a lot neater. Now I put a gas discharge tube, one of those gas discharge tube arresters, on the incoming mic line, so if any static charges or if any side flashes from lightning should ever hit the mic cable, they'll be immediately shunted to ground by a telephone line type protector. Now I also use a pair of diodes connected in parallel in reverse directions as a static discharge, and it goes from the ground side of the audio to the AC line ground. We also replaced the 2-conductor cord with a 3-conductor grounded cord, so that allows me to use the static discharge devices and have a safety ground for them to dump into. So now we have the audio grounds with a discharge path, and the switch box, surprisingly enough, has separate grounding system for the video, and that's the weak point where I think that's where the surge, because of the different ground potential between the phone line and the direct TV ground, I think that's where it got in and destroyed the video input number 2. Front panel on that recorder is number 2. It got in there and destroyed front panel video input number 2. Opened the unit up and I didn't find anything burned or blown up near the jack, and managed to trace the video signal all the way to the back of the circuit board into the video processor IC, and apparently the IC has inputs for front and back, so the switching's done there. Blew the chip, and with that being the case, I'm now pretty much relegated to using the rear inputs, and fortunately, since I now have grounding protection, I should be able to withstand a much harder discharge. You know, when the one comes along that finally takes it, it'll take a much harder one than this one. So that's pretty much it. Well, it's quite a setup because I managed to record the strike that got it. So that was kind of cool in itself. And now it's hardened. It's a little bit tougher and a little bit rougher and safer by all means, because now it's grounded to the AC power. So that's pretty much all the chattering I'll do about the still shot number 1. Still shot number 2. This is an APC surge protector outlet strip, and it also happens to have a pair of what they call MOVs, short for metal oxide varistor, a couple phone line protectors, and a set of phone line fuses. And like the DVD recorder, not much energy got inside of it, just enough to pop the fuses. And clear glass cartridge fuses are kind of handy because they give telltale sign of whether it was blown by a mild overload or a real bad surge. And the fuse link will vaporize on a real hard surge, and on a mild surge it will leave the glass clear, and the hard surge that vaporizes the fuse element will turn it black or silver depending on how the metal vaporized. So it was real light damage, and I'm kind of suspicious. The most suspicious scenario that I can think of is that because of the different ground potentials, surge came in through the DirecTV satellite receiver and somehow cross-connected with the phone line, because blew a video input on the DVD recorder, blew the fuses in the surge protector, and it didn't blow the fuse in the cordless telephone, but it shorted out the switching transistor that more or less takes it on and off hook, the switching transistor that turns phone line on and off. So this was a simple fix. I didn't have fuses, so I took some very, very fine wire that would blow at less than an amp and just soldered it across the fuses, and that still allows protection. The wires will pop if another surge comes along. It's remarkable though, there's no damage, no physical damage inside this unit either. So that's it for number 2 still picture. Here's the VTech cordless telephone base, which is also a digital answering machine. They're not that expensive, about $50 or $60. I would have let this one go, but I just got done buying new batteries for both handsets, so I had a little bit of money tied up in it, and I went ahead and repaired it. It's kind of tough because I pulled all 4 of the little TO92 transistors from around the phone line where it came into the circuit board. So I knew one of them had to be the switching transistor, and apparently I checked, I guess I went collector base and emitter base on them, and didn't check collector emitter the first time around, which I should have done, because that's a path through the transistor that it switches the phone line. It usually uses a collector emitter connection to switch the phone line on and off, and I didn't check in that direction, so I didn't see it the first time around. We'll go ahead and pause. That's about all I can say about that. Let's see. I think, look at my list here, yeah. Next still shot will be number 4, and it'll be a picture of the little note where I made a note of some of the characteristics of the transistor, and I stuck the old one on there so I'd have it for a reference, and then I also went ahead and put a little more information on it. We'll pause and go to that. Okay, here's my little cheat sheet that I made. I pulled an MPSA 94 transistor out of it. That's a PNP high voltage, low current, small switching transistor. It's rated at 400 volts, and normal phone line voltage is either 24 or 48 volts depending on what kind of system you use. And my transistor, it's a Japanese PNP. It's only rated at 300 volts. It's still a pretty fair safety margin. Eventually I'll go back into this phone and put a MOV across it, an MOV, put one of those metal oxide varistor type surge protectors in it just for extra protection. It shouldn't be necessary. So we'll go on to shot number 5 and explain why. Since we sustained damage, and since I'm kind of an electronic tech who knows how to take care of himself, I went ahead and installed some protective components into our system. The device on the left hand side, that little kind of rosy pink looking thing with the 3 heavy leads, that's called a gas tube arrestor. And what that thing does is at about 230 volts, which is still within the range of what more or less will not damage telephone equipment. Phones, they ring at about 90 volts between the normal DC that sits on it and the ringing voltage. Phones can experience up to 90 volts in normal operation, so to allow a few hundred before you start the protection mode, that's good enough. This device, they're only about $2. They're made by Little Fuse. They can be ordered through Mauser Electronics. This device clamps the voltage at about 230 volts DC, and it's sturdy enough to carry a peak of up to 10,000 amps. And I know they'll carry it because I tried to use one for an AC surge suppressor, and I found out that when they fire, they lock up and they'll keep conducting until something blows. And because I was smart enough to have fuse links in my experimental unit, it just blew the links right away. But they're tough. I really believe if lightning hits hard enough that this surge arrestor will hold until the phone wire actually blows in two. It's a remarkable device. Now the diodes on the right hand side, they're connected in parallel in opposite directions, and I also use a 0.1 microfarad disc capacitor. Well, this one's a epoxy mylar, yeah. Usually use a pair of diodes in parallel, reverse directions, and a 0.1 microfarad mylar capacitor. And what that capacitor does, it keeps any RF voltages from being rectified by the diodes and causing interference. These are 1 amp diodes, and I use those in the ThunderMike and in small AC operated equipment. I usually try to use diodes that are rated pretty much equal with whatever the amount of current the device draws. Like when I put one in a stereo receiver, I'll use heavier diodes like 6 amp diodes, but for the small stuff, little 1 amp diodes are fine. especially if I use them in signal circuits or small DC operated equipment. They're very cheap and they're good protection. So that's pretty much it. The gas tube arrestor, let's see. I'll show you where it's used in still shot number 6. So we'll go ahead and pause. Okay, here's still shot number 6. On the right hand side at the baseboard, this is the incoming phone line. This line goes down under the house and out directly to a network interface box on the southeast side of the house. I haven't really dug around the grass to see it, but the last time the phone company was there to work on that box, which was I think in 06 or 07, we had an air conditioner that was alleged to have lost its compressor due to a nearby lightning strike, so the HVAC man told me to have the phone company ground the box properly, so I did, and the phone company says there's a ground rod on it, so as far as I know, the phone interface box is grounded at the back end of the house. Now, to protect the phone equipment, since we already sustained a loss, I took an old DSL filter, which is just the right size, and it's got a little pigtail where the phone line comes in and a little jack on the end. Perfect container, perfect little box to put it in, so I went ahead and put one of my gas tube arrestors in there. The wiring's a little tricky because the phone wire going up to the phone is gray and the ground wire is a 14 gauge, kind of a dark green wire. They look like they go together, but they really don't. The one coming out of the middle of the surge protector goes straight to the grounded screw on the outlet, and then that one on the left, it is a base cord that goes up to the telephone. So now we have the phone line protector. It clamps at 230 volts, and as far as I know, it'll hold until that pigtail blows into, if anything should try to come into the house through that path. So that's pretty much it for number 6. Okay, this is the whole house surge protector. I was blessed that this thing didn't sustain any damage. That black spot on the right hand side near the bottom of that stack of 4 varistors is where the fuse link blew before when I was trying to use a gas tube. Gas tubes don't work across the AC line. When they short, when they conduct, they'll lock on, and that's what they did. They locked on and blew the fuse links. So of course I don't use gas tube arrestors across the AC line. Not a good idea. These varistors are less than $2 a piece. Not sure what the firing voltage is on these. They probably, I don't know, probably fire somewhere around 230 volts. They're also rated at 10,000 amps. So a set of these, 4 on each side of the AC line, is supposed to hold, especially since these are matched, came from the same purchase. These should hold about 40,000 amps and should protect the house against incoming surges. In this event, this is not a picture after the lightning strike, but I did inspect the unit, found that the fuse links had not been heated, none of the varistors were cracked, so the varistors and capacitors and fuse links, everything held up fine. It's in an aluminum case, so if worse came to worse, it'd just get hot and it shouldn't be able to do anything. If it blew up, it should contain it. That's pretty good size, pretty good thick walls on that case. It sustained no damage. Yeah, I'm not a very good artist, but this is kind of a picture of the way things are set up in this house. This house is actually a double wide trailer on a brick foundation. Let's go through it. Start from left and go to right, I guess. Okay, on the side door on that deck, right on the inside of that side door on the wall on the left is the breaker panel box. And as far as I know, there's no ground rod on the east side of the house, as you see by the compass rose. If you're looking at the house, you're looking south, and on your left is east, and on your right is west, and behind you is north. See the dotted lines? The telephone network interface is on the back of the house in the southeast corner of the house next to the air conditioning unit. That's why the story that the airman told me, the air conditioning man told me, that the phone wasn't grounded properly and it took the insulation in the compressor and blew it. I believe it. So the air conditioning unit on the back of the house too, in the southeast corner, right next to the phone box. And on the gable peak of the roof, or whatever they call that thing, is the 18-inch direct TV satellite dish. And it's grounded over here on the west side of the house. We have the phone line comes into the west side and it runs under the eave of the house and drops over there by the interface box on the east side. The satellite dish, like I said, it's grounded over here. They use some kind of clip the installers use. It clips onto the meter base. The meter base is grounded through a ground rod, and I see the conduit going to the ground. I haven't dug it to see if there was a ground rod in it, but I think there's one in there. The panel in this particular house, since it's a trailer, has a sticker on it that says that it's required to be fed from no greater than a 200 amp protective device. So on the west side of the house is a 200 amp breaker. So as far as I know, the grounds for the electric service are totally on the west side of the house. And incidentally, the plumbing in the house is polybutylene or some type of plastic, and I'm not sure if the incoming water line is metal or not. If it is metal, I would expect that the electrical power ground should be bonded to it. I'm looking actually to have the electrical service moved over to the east side of the house, but whether or not it gets moved, I don't know. But the one thing I do need to do is find out if codes will allow a second ground rod, because I really kind of feel that it needs to be grounded on, needs to have a ground rod on the east side of the house. Anyway, I'll consult with an electrician to find out what we can do about that. And I think the power company, I think they may come out here and do an evaluation as well. But that's pretty much it. The house is kind of a sitting duck for lightning damage, at least low-level damage, because we have two systems that are grounded on opposite sides of the house. So what I'm thinking is a lightning strike somewhere less than 1,000 feet from the house, because Lord knows it was loud. It caused a voltage difference between the two grounded sides of the house, caused surge current to flow through the electronics, and that's what took the stuff. I'm not complaining, because I was a tech for 27 years. I knew how to fix the damage. It wasn't that big of a deal. Nobody was injured. There wasn't anything blown hard enough to have started a fire, and the whole house surge suppressor didn't overheat and didn't blow up, so we weren't in any danger. The losses were pretty small. I had enough parts in the junk box to take care of the phone, and everything else was just kind of a no-brainer, no-cost type deal. We were very fortunate. And, you know, my damage won't even make a deductible on homeowners, so Mom and her homeowners are fine. Homeowners insurance is fine. And that's pretty much it. That's what all happened. It kept me busy last week. Being an old dog like I am, I don't have the energy to play with stuff like I used to, but as you can tell, I've protected it. I've hardened some of the equipment that was in the line of damage and line of fire, whatever you want to call it. So that's pretty much it. 10 loop wrench took a lightning hit. Yeah, I think, okay, let's make this official. Take a pause. So there we go. Thank you, ladies and gentlemen of YouTube, for watching. This was kind of an interesting video to do. I'd never in my 55 years thought that I would actually see lightning damage, but it happens. Happens to the best of us. Happens at 10 Loop Ranch. So until we have another adventure at the ranch, y'all keep looking, see what I'm doing, do some crazy stuff. Sometimes I do some serious stuff. Sometimes I just play records. Ain't no telling what I'm going to do. But this is Edgar at 10 Loop Ranch, thanking you for watching. Y'all be careful. Y'all be blessed. And be sure to tune in again, see what there is to see. Thanks, guys. Bye.